So this is the Chapter 4 review, and to save time, I am not going to write down the problems. I'm just going to have them on my sheet of paper so you can look from your review and look at the problems. So the first one, we need to describe how y equals negative 2/3 x minus 7, the quantity x minus 7 squared minus 8 has been translated from the parent graph y equals x squared. Well, the first thing I see is a negative, so that means there's a reflection. And since it's outside, it's been reflected over the x-axis, and a reflection over the x-axis would mean I would multiply my ups by -1, so all my ups would go down and my downs would go up. Then the next thing I see is a 2/3, so that is a vertical stretch or a compression. Since it's less than 1, it's a compression. If it were greater than 1, it would be a stretch, so a vertical compression of 2/3. Then I have inside the parentheses x minus 7. That's a left and right translation, and it does the opposite of what you think it's going to do. So it is a shift right 7. And then after it, I see a minus 8. That is a shift up and down, but it does what you think it's going to do. So it's negative, so it goes down 8. Number 2. For 3 times the quantity x plus 4 squared minus 10, find the vertex. So this is in vertex form, so it will be easy to find the vertex. We do the opposite of the inside, so -4, outside stays the same, -10. So find the vertex and then graph it. Luckily I have a little graph right here. Okay, -4, -10. So there's my vertex. And then the growing pattern on this is over 1, up 1, over 2, up 4, over 3, up 9. And then also the other side, left 1, up 1, left 2, up 4, left 3, up 9. Let's change that to a 9. And since I have a 3 at the beginning, that is a vertical stretch. So that tells me that all of these numbers are going to be multiplied by 3. So I'm actually going up 3, up 12, and up 27. That one probably won't fit on my graph. Going up 3, up 12, and up 27. So over 1, up 1, 2, 3. And same thing on this side. And I'm not going to get that 27 on there, so I'll just graph this in. It's a really skinny parabola. Oops, no, graph that next line. Oh, and I ran into my tape there, so I'll just do my best. Okay, then C on that one asks me to find the domain. Well, the domain of all parabolas is all real numbers. Remember, you can also say -infinity to infinity. And then D asks me to find the range. To find the range, I scan the bottom to the top. So the bottom starts at -10. It actually touches, so I need a bracket. And the top is infinity, so infinity sign. And you can't actually touch infinity, so it gets parentheses. 3, I need to find the vertex for y equals 3x squared plus 9x minus 20. So to find the vertex, to find the x value, I do opposite b divided by 2a. So my b is -9 divided by 2 times 3. So that's -9 over 6, which simplifies to be -3/2. So that's part of my vertex. And then to find the other part, I sub that in. So y equals 3 times -3/2 squared plus 9 times -3/2 minus 20. So find a calculator, we'll punch that in. 3 times -3/2 plus 9 times -3/2 minus 20, and I get negative 107/4. That's a fun vertex. Glad we're not graphing that. Okay, it also wants us to find the y-intercept. The y-intercept is 0c, so c is negative 20. So those are my two answers. 4, I need to find the vertex and y-intercept for y equals negative 2x squared minus 4x plus 6. When I do the vertex, still it's opposite b divided by 2a, so 4 divided by 2 times negative 2. So 4 divided by negative 4, which is negative 1. Then to find my y, I plug that back in. So y equals negative 2 times negative 1 squared minus 4 times negative 1 plus 6. So my vertex is going to be at 8, negative 1, 8. This one I do have to graph. Does it tell me to find the y-intercept? Yep. We need to find the y-intercept also. So the y-intercept is at 0c, 0, 6, and we need to graph that now. So negative 1, 8, and then this has a vertical stretch of negative 2, or it has a vertical stretch of 2, but it says negative 2, so that means it's gonna open down. I'm gonna multiply all my ups by negative 1. So instead of going over 1 and up 1, I'm gonna go over 1 and down 1 times 2, so 2 over 1 and down 2. And that also gets my y-intercept at 0, 6. Then I'm going to go over 1 and down over 2 and down 4 times 2, so 8. Which will get me down here. And then I'd go over 3 and down 9 times 2, so 18. Which will put me down here at 10. And then just like all parabolas, that would have a domain of all real numbers. The range on this one is different, so even though it doesn't ask for it, I'm going to go ahead and throw that in there. The range on this one, the bottom is at infinity, so it starts at negative infinity and goes up to 8, and then the bracket is on the other side. So when your parabola opens down, the infinity will go... Oh no, did I just do that whole problem without you being able to see it? Awesome. I hope not. When you do the range of a parabola that opens down, the infinity goes first, and it's negative because it's the bottom, and then the top is the y value of your vertex, and it gets a bracket always. Okay, so next, a company's revenue, blah blah blah, and we can use our graphing calculator. So to use our graphing calculator, we turn it on, go into y equals, and we type in our equation. Negative 1.5 p squared, and we use x for any variable, plus 100 p plus 500. And if I graph that, I bet I can't see anything, correct, because this is going to go up to 500, and my window is only showing me up to 10. So I need to make that bigger, let's say 1,000. And I probably should make my x max bigger so I can see that as well. Then I'll press graph again and see it. Oh, nope, it's still too tall. I still can't see it, so let's just double it. Oh, no, not going to 2. 2 will not help. I meant to type 2,000. Let's see if that'll work. Okay. So I'm looking for the place where this will be maximized. So the maximum, remember, is the top. That's also the vertex, so if you didn't want to use your graphing calculator, you could do opposite b divided by 2a to find your x value. But that finds the price, then you'd have to plug it back in to find the revenue. So this is a little bit faster. We'll do second trace, and to find the maximum we'll use number 4. And we'll press the left arrow because it asks for the left bound, so we need to go left of this maximum right here. Enter. Then go to the right, because right now we're telling the calculator to look in between what two values. There we go. And the maximum is 33 1/3 and 2,166.67. And it's asking for the maximum revenue for A. So this X is P, and P is the price. So Y will be my revenue. So for 5A, it asks for my revenue, and they were probably selling things and pricing them in dollars, so I'm going to price it in dollars. So that means if it's dollars, I'm going to round to cents, so 67 cents. And then B says, what is the number of Christmas stockings that maximizes this revenue? Well, it's 33 1/3, but you can't sell 1/3 of a stocking, so 33 stockings. Okay, 6 wants me to change this to vertex form, so probably I should find the vertex. So opposite B, -8 divided by 2 times -2, so -8 divided by -4, which is 2. So my vertex is at 2. Then I plug that back in. -2 times 2 squared plus 8 times 2 plus 3. And when I do that, I would get 11. So I know my vertex is at 211. So it's y, vertex form is y equals a times x minus h squared plus k. And this one was in standard form. So this is A, B, and C. Notice the only one that carries over from here to here is A. So y equals -2 has to come over from here. And then x minus, this is my h, and this is my k from the vertex, x minus 2 squared plus 11. Next page. Okay. Solve by factoring. Can probably fit that on here. We have -x squared plus 11x minus 18 equals 0. So the first thing I have to do is find a GCF. Remember, in factoring, you don't want this first term to be negative, so factor out a -1. X squared, that will change all my signs. Minus 11x plus 18 equals 0. Then I multiply my a times c. A is 1, c is 18, so I have 18. The factors of 18. The factors of 18 are 1 and 18, 2 and 9, and 3 and 6. And I need to figure out which ones add to give me -11. So they have to multiply to give me positive 18, which tells me both are going to be positive or both are going to be negative. But to give me -11, they're going to both have to be negative. So the way I get -11 is 2 and 9. So I have -1 x squared minus 2x minus 9x plus 18 equals 0. Okay, now what do these first two have in common? Well, I can factor out an x, and that leaves me with x minus 2. Now on these two I can factor out a 9, but it needs to leave me with x minus 2. Right now my sign in between them is a plus, so to change that I'll factor out a -9. Okay, now -1, x minus 9, x minus 2. And I did run out of room. I'll do this over here though. Okay, over here. Now I take each piece that has an x and set it equal to 0. So x minus 9 equals 0, and x minus 2 equals 0. So we add 9, x equals 9, we add 2, x equals 2. Number 8, we have another one to solve by factoring. Let's see, 3m squared plus 7m minus 20 equals 0. So there's no GCF on this one. So I do a times c. 3 times -20 is -60. And then I need to make my factors of -60. So since it's a negative, it tells me 1 is going to be negative. 1 and -60, 2 and -30, 3 and -10, 4, oh, negative 10. What's going on here? 3 and negative 20. 4 and negative 15. 5 and negative 12. Okay, there it is, but I have this right now would give me negative 7, and I'm looking for positive 7. So it tells me I have my negative on the wrong one, which I should have known because that's the positive, so the bigger number should have been positive, but I wasn't paying attention. So 3m squared minus 5m plus 12m minus 20 equals 0. What do those two have in common? What do those two have in common? Well, here I can take out an m, and I have 3m minus 5. Here I can take out a 4, and I have 3m minus 5. So I have m plus 4 and 3m minus 5. Now I set those both equal to 0, so subtract 4 from both sides. This one's just going to be negative 4. This one requires a little bit more work. We have to add 5 to both sides, but then I still have 3m equals 5. So I divide by 3, and I will leave that as a fraction, 5/3. 9 solved by factoring, 81x squared plus 36x plus 4. Okay. Now remember, we have those two special kinds of factoring, difference of squares and perfect squares. Remember, difference of squares only has 2 terms with a subtraction sign in between. Perfect squares looks like this with 3 terms. So I'm going to check and see if this is perfect squares. So can I take something and square it and get 81? And can I take something and square it and get 4? Well, yeah, this is 9. Oh, I forgot my x squared, 9x. And this would be 2. So then my middle term always has to be 2 times whatever I had here times whatever I had here. Well, 2 times 2 is 4, and 4 times 9 is 36, so this does fit my pattern. So this will factor as whatever this one was, whatever that one was, this sign squared. And then I just set that equal to 0. There's 2 of them. So I only have to do it once. So 9x equals negative 2, so x equals negative 2/9. And if it had just said factor, I would end here, but since it said solve by factoring and was set equal to 0, I needed to continue to go down to x equals. 10 is a solve by graphing, so let me grab my graphing calculator. Turn it on, hit y equals. We will type in this equation, 0.5x to the third minus x squared minus 8x, and I'm going to hit zoom 6 to take me back to zoom standard because my window was crazy from that other one. Okay, so to solve, we're looking for the zeros, so we're looking for the places that it crosses the x-axis. And to do this, I'm going to hit second trace, which is calculate. I'm going to calculate the 0. So it asks me for the left bound, so I'm going to go find the leftmost one first. So I'm looking for this point. I'm left of it. Now I'm right of it. Enter, enter. And my 0 is at negative 3.123. And then my next one, left of it this time, is above it. And now right of it, below. This is at 0, and then my last one, left of it, is again below, and right of it is above, so 5.123. Alright, that's done. 11, solved by completing the square. X squared minus 12x equals negative 11. So to do this, the first thing you need to do is make sure your x's are on one side and your numbers on the other, which we have going on. Then I need to do over to the side b divided by 2, so negative 12 divided by 2, which is negative 6, and that's the number we're going to keep later to factor, but for right now we square it, and it's 36, so we add that to both sides. So I have x squared minus 12x plus 36 equals 25. Oh, good. Now this side factors as x, and then whatever this sign is, so minus subtraction, and then whatever this number was. Or just x, and since that was negative 6, you would know it would need to be subtraction. So there's a couple different ways you can tell. Once I have that factored, I need to take the square root of both sides. So I have x minus 6, and since I put the square root sign there, it needs to be plus or minus 5. So now I'm going to split it. X minus 6 equals 5, and x minus 6 equals negative 5. Add 6 to both sides, x equals 11 here. Add 6, x equals 1 there. 12 solved by square root method. Okay, we need to isolate the squared thing, so this whole parentheses is the squared thing, so I have to get rid of the 3 that's on that side, but not in the parentheses. Then I take the square root of both sides, and once again, since I wrote in the square root sign, it needs to be plus minus, and since it's plus minus, I'm going to split it into 2. X minus 8 equals 3, and x minus 8 equals negative 3. Add 8 to both sides, so x equals 11, and add 8 to both sides here, so x equals 5. And then we are on to our next one, 13, where we need to solve by quadratic formula. I don't see a GCF on that one, so I'm just going to start. X equals opposite b plus or minus the square root of b squared. I go ahead and square that, and remember to make sure this is always a positive number, minus 4ac, divide all of that, make sure your division sign goes clear over here, by 2a. Okay, so negative 5 plus or minus 25 plus 4 times 2 times 7. Okay, so that is going to be 81 divided by 4. So negative 5 plus and minus 9 divided by 4. And we need to split that into 2. Negative 5 plus 9 divided by 4. And negative 5 minus 9 divided by 4. So negative 5 plus 9 is going to be 4. 4 divided by 4, here x will equal 1. Negative 5 minus 9 is going to be negative 14 divided by 4. Those can both divide by 2, so negative 7 halves is what x is going to equal here. I have one more sheet of paper? Okay. 14. 14 is going to be pretty fast. The discriminant of a quadratic is positive, so that quadratic has exactly 2 solutions. When it's positive, when the discriminant is 0, it has 1 solution, and when the discriminant is negative, it has 0 solutions. 0 real solutions. There will be some imaginary. Okay, 15. We have the square root of negative 72. Well, we can split that into the square root of 72 and the square root of negative 1. Remember, that's going to give me my I. And then for 72, I need to do a factor tree. So that divides by 8 and 9. 8, sorry, I have the hiccups. 8 divides by 4 and 2. 4 divides by 2 and 2. 9 divides by 3 and 3. Okay, so it looks like I've got a pair of 2s. I've got an extra 2 that's not in a pair, and a pair of 3s. So my pairs go outside, 2 times 3. My I also goes outside, but this 2 that didn't have the pair stays inside, and then I multiply. So 6i square roots of 2. 16, all I need to do is add. So I'm looking up there, it looks like my like terms are 8 and negative 1. Well, let me just go ahead and write that out. 8 minus 2i plus negative 1 minus 6i. Okay, 8 and negative 1 are my like terms, so that would be 7. Negative 2i minus 6i would be negative 8i. That one's done. 17, negative 6 minus 7i minus 1 minus I. Okay, when we have subtraction, we're going to go ahead and change this middle sign to addition and distribute that negative. So both of the signs in the set of parentheses after it will change, and now we treat it just like addition. So negative 6 plus negative 1 is negative 7. Negative 7i plus 1i is negative 6i. And now 18, I have to, okay, notice those two had signs in between, an addition and a subtraction. On 18, there is nothing in the in between the parentheses, which means we FOIL it. So negative 4 times negative 1 is negative 4. Negative 4 times negative 3i is 12i. Negative 2i times negative 1 is negative 2i. Negative 2i times negative 3 is positive 6i squared. Now combine your like terms. Remember that I squared equals negative 1. So positive 6 times negative 1 is going to be negative 6. So then I combine like terms again. Negative 10 plus 10i. Remember, on all of these you need to write the number without an I, your real number first, and your imaginary number second. Okay, 19, where we have to divide. This is going to cause a lot of work. Okay, 4 minus 2i. So on this one, we have to multiply by the conjugate of our denominator. So we look in front of the I term and change the sign.